Hello, what's up guys? Regine again here. For this particular topic in foundation mathematics, we're going to talk about partial fractions. So what are partial fractions? So when we discuss about partial fraction is the way that we're converting the rational expression or combined rational expression into several factorial factors. Kumbaga, diba meron tayong rational answer. So what we're going to do is, i-break down natin siya ulit at gagawin natin siyang factors of several fractions. So a rational fraction is the quotient of two polynomials. So alam natin na yan ang tinatawag natin na rational fraction. So review lang natin ng konti. So ano ang proper at improper fraction? So when we say that's a proper fraction, that means the value of the numerator is less than the value of the denominator. And if it's improper, the value of the denominator is greater than the numerator. So that way, we can say that the fraction is improper or proper. So say, for example, of a proper fraction, so we have 3/5. What else? We have 2/3. So those are proper. So when we say improper, so mas malaki yung value ng numerator. See, for example, 5/3. Yan. 10/2. But this can be lowered down to 5/1. And eventually, that's 1 or 5. And that is a whole number. What else? 13/4. Yan, yung mga ganyan. So those are improper fractions. So sorry for that noise. That's my cat. Okay. So sabi ko hindi ko na inalis yung mga adlib. So let's have here a warm-up. Okay. So what if we're asked to simplify this one? So the first thing that we're going to do is to first find the least common multiple of this function. That's my cat. I'm discussing. So the least common multiple of the two, that would be the product of this and this. So that would be, so we're going to combine that. That becomes x minus 2, x plus 1. Then we multiply that with also with this. So x minus 2 and x plus 1. So x minus 2 and x plus 1 divided with x minus 2. So that would be x plus 1. So therefore, that would be 3 times x plus 1. We carry over the sign positive. This divided by x plus 1. Okay, so that would be x minus 2 times 2. So distributing this and then combining the similar terms. So we have here 3x plus 3 plus 2x minus 4 over x minus 2, x plus 1. So 3 and 2x, so that would be 5x. 3 and negative 4, so that is negative 1 over x minus 2, x plus 1. So this is just a review of the fractions. Okay. So hope you still recall this way back your senior high school years. Okay. So let's now have another warm-up here. Okay. So what if you ask to decompose this one into prime factors? Okay. So we have their x squared plus 5x plus 6. Okay, so what are the factors? So we take the factors of this one and then the factors of this one by factoring. So x squared, that's 1, so that is 1 and 1. And 6, that would be 1 and 6, 2 and 3, and then it will reverse. So let's try 1 and 1, 2 and 3. Crisscross. 3, 2. Can 2 and 3 form 5? Yes, if you add both. And then by sign convention, we have here positive and positive, which means the signs in the parentheses would be both positive. So that would be x plus 2, x plus 3. And those are the factors. So let's just have a record for this one regarding to factoring. Assuming we have the general form, a squared plus 2ab plus b squared, a squared plus, or rather minus, 2ab plus b squared, and then a squared plus 2ab minus b squared, and then a squared minus 2ab plus b squared. For this case, both are positive. For this one, both are negative. And for this one, depends on the sign convention. So 1 plus and 1 minus. 1 plus, 1 minus. So those are just some of the things that we need to understand for this one. So 1 plus and 1 minus. So for that case, plus here and plus here, that would be both are positive or both are pos. Okay, we have here a critical thinking question. So how do we compose a rational expression? Okay, so that is the agenda of our discussion for this session. So that would be resolving partial fractions. Okay, so how do we resolve partial fractions? Actually, we have here 3 cases, or we have here 4 cases. The first case would be a linear denominator that is not repeated. So what do we mean by that? Say, for example, we have the general form. Suppose the numerator is a function of x and the denominator is in linear form. So generally, what is the linear equation form? So that is y equals to mx plus b. Suppose the function has several factors there. That would be a over mx plus b. So if there is 2 factors that is not repeated, so suppose you can write it like this. So f of x, 2 factors such as what is written above. So we have here m1 x1 plus b1, parenthesis, m2 x2 plus b2. So that it will look like a over m1 x1 plus b1 plus b over m2 x2 plus b2. And if that would be several factors, so suppose we have n numbers, so n over mn xn plus bn. So something like that. So as long as the factors are not repeated, that means those should be distinct. Dapat magkakaiba sila, else that would be another case. Okay, let's have some sample problems. So we're asked to decompose this. So kanina ginawa natin ito, dinala natin doon. So ngayon ang gagawin natin, from this one, ibabalik natin siya doon. So paano natin siya gagawin? Okay, yan ngayon yung pinaka-topic natin dito. So we will decompose 5x minus 1 over x minus 2, x plus 1. Okay, so we have here 2 linear factors that are distinct. Therefore, this is an example of the first case, or case 1. Okay. So we can decompose this. Since we don't know the constant yet, or the arbitrary constant yet, we will represent that with the letters A over the first linear factor, x minus 2, plus the other arbitrary constant B over the other linear factor, x plus 1. So how do we resolve this now? Okay. We will multiply everything by this common multiple, x minus 2, x plus 1. Multiplying this to everything would lead to a single line equation, which is 5x minus 1 is equal to a multiplied by x plus 1 plus b multiplied by x minus 2. Diba? I-distribute mo siya dito, magiging 5x minus 1. I-distribute mo siya dito, x plus 1 lang matitira, i-multiply mo kay a. At dito naman si b, at i-multiply mo kay x minus 2. Now you have here a single line equation. What you're going to do next is to distribute the coefficients. So we have here 5x minus 1. Okay. But before that, let me teach you this technique. So in resolving partial fraction decomposition, so we have 2 methods. The first method is what we call the coefficient cancellation. And 2 by systems of equations. So we're going to do both. Okay. So for coefficient cancellation, that means one constant will be canceled out by making this parenthesis equal to 0. So how can we make that a 0? So there are two possible values for x's that could lead to the cancellation of each. So x can be equal to -1 for this one, and x can be equal to 2 for this one to become 0. So let's first test at x equal to -1. Okay, so we substitute. So evaluate the functions of this one as function of x. So therefore, we have here 5 times -1 minus 1 is equals to a, -1 plus 1, plus b, -1 minus 2. -1 and 1 will be cancelled out, so this becomes 0, so we can neglect that. So we have here -5 minus 1 is equal to negative b, or rather, let's solve what's inside first. -1 minus 2, so this is -3. Negative and positive, so that becomes negative 3b. -5 and -1, this equal to -6. This equals to -3b. So we already have our value of b equal to 2. So that's the coefficient for e. So how do we now solve for our a? So to solve for our a, we let x be equal to 2. So that becomes 5 times 2 minus 1 is equal to a, 2 plus 1 plus b, 2 minus 2. 2 minus 2 is equal to 0, so therefore we can cancel this out. So 5 times 2 minus 1, so that would be 10 minus 1, so this is 9. Is equal to a, 2 plus 1, so that is equal to 3. So we have here 3a. So that the value of our a is equal to 3. We will now substitute this back to this equation. Kanina, hindi na-compose natin. So that we can now rewrite that as 3 over x minus 2 is plus 2 over x plus 1. And we know that this is the original equation that we are solving. So that would be 3 over x minus 2 and then 2 over x plus 1. So that is by the coefficient cancellation. I'm going to show you the systems of equations in the next example. So questions and clarifications, you can ask me questions if that will make you more comfortable in your learning process. So let's now have the second case. So that is a linear denominator that is repeated. So for a linear denominator that is repeated, so the functions of x will be also the same, but this time, the denominator has a linear factor that is repeated. This usually occurs with the perfect square trinomials na may factor na gano'n. So see for example, m1 x1 plus b1, naulit siya. Dalawang gano'n. So pagka ganyan, ang ginagawa natin is a over m1 x1 plus b1 plus, please take note, yung b is same pa rin sa kanina, pero nagiging squared ito sa may pang ilang iteration siya. M1, X1 plus B1. Quantity squared. Okay, question. Paano sir pag 4 na beses siya na ulit? That means magiging raised to 4 siya sa may pang-4 if pang-4 siya. But for that case, since this is double repeated, that means dalawa lang. So we can rewrite that form as f sub x over m1 x1 plus b1 raised to n would be equal to a over m1 x1 plus b1 plus b m1 x1 plus b1 quantity squared plus dot 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 plus, okay, so kung pang ilang alphabet man yan, alphabet n over m1 x1 plus b1 quantity raised to n. Okay, so ibig sabihin, nag-repeat siya kung ilang beses mo siya ginamit. Okay, so let's have now a sample problem. Ayan, decompose into partial fractions. So kung makikita nyo, meron siyang naka-square dito. Mean to say, meron tayong dalawang na ulit. So, paano natin siya ngayon isosolve? So, ganito siya ngayon. So, hope i-copy nyo muna to habang ano. Okay, you can pause and then copy the solution. Okay. So, 7x squared plus 3x plus 2 over x minus 2, x plus 1 raised to squared. Okay. So how do we first form the decomposition equation? So that would be, so take this first, a over x minus 2, plus you take the first repetition, b over x plus 1. And since that is repeated for the second time, we have another arbitrary constant, x plus 1 raised to squared. So since that this is the second time that it will be used. Okay. Now we're going to multiply. So just like what we did in the previous example, we will multiply everything by the least common multiple of the denominator. So that would be x minus 2, x plus 1 raised to squared. Okay. To form a single line equation. So by that, so if you multiply this one by this one, what was left is 7x squared plus 3x plus 2 is equal to, if you multiply this one with this one, so therefore that would be a quantity x plus 1 quantity squared. If you multiply this by this, so that would be b over b times x minus 2, x plus 1. And then that would be c times x minus 2. So kung papansin nyo, single line equation siya. Okay. So pag ginawa nyo ganyan, nag-coefficient cancellation tayo, if we equate x equal to negative 1, 0 to, pero ito hindi. Pag nag-2 ka naman, 0 to, at ito hindi. May maiiwan na isa, which is something tedious. Okay. So ano yung pwede nating remedyo dyan? So gagamit tayo ngayon ng systems of equation. So that would be possible, but not enough kasi magkakaroon tayo ng 2 values. Okay, so let's try. Okay, so I have, oops, that's my cat. Woo! Una. Malun kasi siya. Okay. So by using system of equation here, so ang gagawin natin is simplify muna natin lahat itong mga coefficients nila. So that we can write this as 7x squared plus 3x plus 2 is equal to a quantity, so this is special product. So this would be x squared plus 2x plus 1 plus b quantity, first term x squared. So x minus 2x, so that is negative x, and then we have here negative 1 plus c quantity x minus 2. Okay, we will now take it as a coefficient. Okay. So the highest degree, the next degree, and the lowest degree. Okay, so we have here like this. So x squared, x raised to 1, and then x raised to 0. So for x squared, we have, okay, so we will take the coefficients and then equate them. So for this one, we'll take 7 equal to okay, a plus b, okay, and then nothing more. For x raised to 1, so constant x, so we have here 3 equal to 2, okay. Then take this, 2a, and then minus b. And then for x raised to 0, that will be the constant alone. So we have here 2 equal to a minus b minus twice c. Oops, we have forgotten to write this one. So we should have here plus c. Okay, so let me double check. So 3, 2a, negative b, and then c. Okay, now we have here 3 equations and 3 unknowns. We will apply. We cannot apply we can apply substitution, but what's more practical is if we apply elimination method. Okay. So though we can also use substitution, it's up to you what is the more convenient process. So for this one, I think using elimination would be a better option. Though we can use substitution and then substitution until we arrive at the right equation. Okay, so let's just use elimination for this one. So let's combine these two equations. So we have here 7 equals to a plus b, and then 3 equals to twice a minus b plus c. If we add these two equations, b cancels out. So this will be 10 equal to 3a plus c. Let's call this as our fourth equation. Let's try to combine these two equations and also eliminate b. Since we eliminated b in the first step, we should also eliminate b on the next or succeeding step, or in the next step. So this would be 3 equal to twice a minus b plus c. And then we have here 2 equals to a minus b minus twice c. So for that case, instead of addition, we'll do subtraction. So you're going to change the signs of the subtrahend. So this would be negative 2 minus a plus b plus twice c. Okay, now, if you're going to add that, so this would be equal to 1 equal to a, oops, what's that? I thought it's somewhat fluctuating. Okay, it's already fixed. So negative b plus b, so this cancels out. And this is equal to plus 3c. Okay. So 1 equals to a plus 3c. So that is be our fifth equation. So we resolve this by combining 4 and 3. So anong gusto natin tanggalin? Oops, nawala ang sulat. Sorry for that. So if you combine that, so try natin tanggalin na lang si a. So to remove a, we need to multiply 5 by 3. Okay, and then subtract. So that 5 becomes, okay, so that we'll have your two equations. 10 equals to 3a plus c. And then we have here 3 equals to thrice a plus 9c. Okay. So if this would be subtraction, so therefore we will have 7 equals to 3a and 3l will now be cancelled. 10 minus 3 is 7. 3 and negative 3a would be cancelled out and 0. And then 1 minus 9, that is negative 8c. So that the value of our c would then be equal to negative 7 over 8, which is the first coefficient. Oops, 8. Let me double check. So 10, 3a, and c. So 10, 3, and c. If we multiply 3, so 10 equals to 3a plus c. And then 3 equals to 3a plus 9c. Okay. So minus, minus, and minus. This cancels out. 7 equals to negative 8c. Okay. So let's see what went wrong here. So let me double check everything here. So actually it should be, I can't see. Let's double check first. So 7a, this is correct. So 3 twice a minus b plus c. 2a minus b minus twice c. Okay. Combining 1 and 2, is cancelled out. Okay, so c3a, okay, 7, so 4. So for 5, combining this 2, so 3 twice a minus b plus c. So negative 2, so since we multiply negative 2 minus a plus b plus 2c. So we'll have here 1 equals 2. 8 plus 6, so that would be 5. Okay. Let us see why it looks like that. So maybe there's an error with this one. That's this one. Let's double check. Oh. So x plus 1 squared is correct. X squared twice x plus 1. X squared plus 1. X plus 1. So we have 2. So x squared minus x. Oh, this should be minus 2, not minus 1. Okay. Okay, saw it. So that should be minus 2. Okay. So this should be twice a minus b plus c. So 3, 2, negative, negative, and plus. But this should be negative 2b. Okay. Instead of b alone. So we've already seen the error. Okay. So combining 1 and 2, so for equation 4 is correct. Okay, so let's redo our equation number 5, which is incorrect. Okay. So sometimes I don't edit the errors in the video so that I can see if you are alert or you can follow the lecture. Okay. So combining 2 and 3. Okay, so 3 equals to 2a minus b plus c. And then 2 equals to a minus 2b minus 2c. Since we eliminated b here, we should also eliminate b in this equation. So to eliminate that, we should have negative 2 for this equation. So that we're going to have negative 6 is equal to negative 4a plus twice b minus 2c. And we have here 2 equals to a minus twice b minus 2c. And combining these two equations eliminates this. So that will have negative 4 equals to negative 3a minus 4c. This will be our fifth equation. Okay, as you can see, we can simply add both 4 and 5 to eliminate a right away. So by adding this, so 10 minus 4, so we have 6 equal to, this cancels out, minus 3c. So that the value of our c would then be equal to 2. We already now have the value of our c. We can substitute that either in equation 5 or equation 4. So for that case, let's just substitute that in equation number 4 since c has no multiplier in equation number 4. So that will have here 10 equals to 3a plus 2. Transposing 2 to the other side, so that would be 10 minus 2 equals to 3a. So that 8 is equal to thrice 8. Okay. Do we have any error here? So let's double check. So 10 plus 3a plus, so c should be equal to 2. Okay, so that's correct. It should be negative 2 according to my answer there. Okay. So what we have there is negative 4 minus 3a minus 4c. So c should be equal to negative 2. I'm sorry for that. Okay. So sign conventions. So if we substitute negative 2 there, so let's try that only number 4 instead. Okay, so that will be the easier solution. So 10 equals to 3a minus 2. Transposing that to the other side, so we have there 10 plus 2 is equals to 3a. So the 12 is equal to 3a. And our a now would then be equal to 12 divided by 3, so that is equal to 4. So we have our c, we have our a. So we can substitute a on the first equation to find our b. So the 7 equals to 4 plus b. transpose 4 to the other side. So we have here 7 minus 4 is equal to B. So that our B is equal to 3. And those are the coefficients. Now that we have all the coefficients, we will substitute that back here. So that the answer would be 4 over what factor was that? X minus 2. 3 over x plus 1. And then negative 2, since that would be negative here. So plus minus, that would be negative over x plus 1 quantity squared. And that is the decomposed fraction and the answer, which is written here. Okay, so do you have any problems or questions with regards to this sample problem? So if you have one, don't hesitate to send me a private message so that I can give you some clarifications that will aid you in your learning process. So we have now here the third case. So the third case will be a quadratic equation, denominator that is not repeated. So what is the look of a quadratic equation? So that is ax squared plus bx plus c. Okay. So say for example, we have function of x, ax squared plus bx plus 1, 1, 1, 1, 1. And we have here another a1 x1 squared plus b2, or rather b2 rather, d2x2 plus c2. Okay, so something like that. So just like what we did with the linear, it would look like this. Instead of a single coefficient, the numerator now becomes a linear function. So that would be ax plus b over a1 x1 squared plus b1 x1 plus c plus cx plus d over a2x2 squared plus b2x2 plus c2. So if we have a repeated fraction, okay, so that would propagate and then interpolate. So let's have here a sample problem. So we're asked to decompose this one. So I think I will just move this since we're running out of space here. Okay. So so let's try to write first the decomposition equation. So the equation would be, okay, so we have here one linear. So for linear, that would be singularly a over the linear factor x minus 1. And since this is a quadratic that is irreducible, therefore that would be plus bx plus c over the quadratic factor, which is x squared plus 4. Let's see, that would be x squared plus 4. Okay, now that we have this, we can now reduce this to, as usual, a single line equation. So we multiply that with x minus 1 and then x squared plus 4. Multiplying everything with this one, that would be 2 4x squared minus 5x plus 11 is equal to a multiplied by x squared plus 4 plus bx plus c multiplied by x minus 1. So for this case, to make it clear, we can write this as 4x squared minus 5x plus 11 is equal to ax squared, okay, a times x squared plus 4 plus bx quantity x minus 1 plus c quantity x minus 1. Or let's distribute x here, so that we'll have b x squared minus x. Okay. So just like what we did with the previous example, we will use system of equation. So highest degree first, so that would be x squared, x raised to first, and x raised to 0. Okay. So how do we do that? So for x squared, we have 4 equals to a plus b. For x raised to 1, we have negative 5 equals to negative b. Okay, so let's just align the coefficient. Negative b plus c. And then for constants, 11 would be equal to, okay, so take the number. Okay, so that would be 4a. For b, we don't have, but for c, we have minus c. So we now have 3 equations and 3 unknowns, and we can now solve for the unknown variables. So let's combine first this one and this one. So that will have 4 equals to a plus b using elimination minus 5 equals to negative b plus c. If we add this 2, b cancels out. So therefore, we have here negative 1 equals to a plus c. Let's call this as our fourth equation. Oops, as you can see, the third equation is also a and negative c. We can combine right away 3 and 4. So we have here 11 equal to 4a minus c. So adding that up eliminates c. So that will have 5a is equal to 11 minus 1, so 10. So that the value of our a is now already obtained, which is equal to 2. So if we have our a, we can solve for our b or c. For this case, let's try to solve for our b first. So we have here 4 equals to 2 plus b, transpose 2 to the other side. So that will have b equals to 4 minus 2, or b equals to 2. So we'll already have our a and our b. So now let's have our c. So how do we obtain our c? So the easiest equation would be using equation number 2. So that would be negative 5 is equals to negative 2 plus c. Transposing negative 2 to the other side. So that would be negative 5 plus 2 is equal to c. And that would be negative 3 is equals to z. Okay. So we'll now have all the coefficients. So since we have already all the coefficients, we can now revert that back by substituting the arbitrary constants. So for that case, so we have 2 over x minus 1, which is our a here, plus our b equals to 2 times x. Our c is negative 3 over x squared plus 4. And that is the answer. And that is how it is. How everything is obtained. Okay, so do you have any problems or questions in regards to this one? So if you have one, please don't hesitate to approach me or ask me some questions. I'll be happy to aid you on your learning process. Okay, now, the most notorious of them all. Okay. Quadratic that is repeated. Okay. That means we have here a quadratic function or quadratic denominator that is repeated. So same with the linear, but this time, it is the quadratic that is repeated. So say, for example, ax plus b over ax squared plus bx squared plus bx plus c. And this is repeated twice. So that would be ax plus b over, oh, I'm sorry, this should be f of x. So ax squared plus bx plus c. And what will happen here? Pause the video for a while. Come to think, if you're ready, you have your answers, play it. Plus cx plus d over ax squared plus bx plus c raised to squared, and as long as how many times it is being repeated. Okay. So let's now have a sample problem, which is the last part of this topic. So we have here this one. So we'll need to decompose this first. So this would be, so 1 linear and then 2 quadratic that is repeated. So that would be a over x minus 3 plus bx plus c over x squared plus 2 plus dx plus f over x squared plus 2 quantity squared. Okay. What we're going to do here now is to do the same. We will reduce this to a single line equation by multiplying with the least common denominator, which is x minus 3, and then x squared plus 2 raised to squared. Okay. So if you multiply that with that one, so the leftmost size would be 3x raised to 4 minus 4x cubed plus 13x squared minus 11x plus 23 is equal to, so a multiplied by x squared plus 2 raised to squared. So bx plus c would then be multiplied by x minus, it should be x minus 3 here. Sorry for that. So x minus 3 and another x squared plus 2, but not squared. And then for the last term, plus dx plus f, that will be multiplied by x minus 3 only. Okay. So we now have a single line equation for this one. So we have here 3x raised to 4 minus 4x cubed plus 13x squared minus 11x plus 23 is equal to a. Okay, so let's try to square this first. So we have here x raised to 4 plus 4x squared plus 4. So for this one, so let's try to combine this first. So we have your x cubed minus 3x squared plus 2x minus 6. So for b, so that would be x raised to 4 minus 3x raised to cube plus 2x squared minus 6x. So for c, that would be as is. So x cubed minus 3x squared plus 2x minus 6. So for the coefficient of d, let's isolate x and then multiply it here. So that would be x squared minus 3x. And then for the coefficient of, okay, what did I use f here? I should be using e first. So let's use e first here. And then for e, we have x minus 3. Okay, so let's now take the coefficient terms. So the highest degree exponent is x raised to 4th. So therefore, we have here x raised to 4th, x raised to cube, x raised to squared, x raised to 0, and x raised to, okay? So x raised to 1 and x raised to 0. Okay. So for x raised to 4, so we have there 3, okay, is equal to a plus b. Are there something more? Nothing else. So 3 equals a plus b. That is called our first equation. So for x cubed, we have negative 4 equals to negative 3b plus c. Okay, so those are the factors. Let's call this our second equation. So for x squared, we have 13 equals to 4a plus 2b minus 3c plus d. Let this be our third equation. So 1. So negative 11 is equal to, none here, minus 6b plus 2c happened. suddenly nawala. Oh. What happened? Suddenly, okay. Oh, what happened with my tablet? Ayun. So negative 11. So negative 6b. What else? Plus 2c. Oh, oops. Let me pause for a while. Okay, so that's what I like with this one. So whenever there are technicalities, so I can cut it short and then I'll just proceed afterwards. So x raised to 1. Oops. What's this? Minus 6b. So negative 6b. So for c, we have plus 2c. Oh, it's gone again. Plus 2c. For d, we have negative 3. And then for e, we have e alone. So that is be our fourth equation. And then constants. So we have 23 is equal to 4a again. So b, we don't have. We have negative 6c. For d, we don't have, but for e, we also have negative 3 equal to, okay, and that would be our fifth equation. So for this one, what can we do? So for this one, we can use multiple substitutions, okay, so to reduce the equation into a single coefficient. Or if we're already versed with the matrix operations, so matrix operations will do the trick. So for this case, let's try to use substitution and another substitution so that we can reduce the variables. What's that? What's this? For that. Okay. So we have here, we can say that our A is equal to 3 minus B. Let this be our first equation. So we can substitute that to any of the equation that we like. So if we substitute that, A equals to negative 3B. Okay. So what else we can substitute? Well, actually, we can just manipulate that and then substitute that to as B rather than A. So, and then bring it here. Or we have two substitutions here. We have A and B substituting as B. Okay. So that B is going to be remain. Okay. So that we'll have here. Okay, so let's take that back. So we have here 3 minus A is equals to B. 3 minus A equals to B. So that would be the first one. So substitute that to here. So we have negative 4 equals to, sorry for that, negative 3 times 3 minus A plus C. So just to omit our B. Or we can use elimination and another elimination for this one. So whichever is the most convenient. So we have a lot of solutions for this one. So if we use that, let's see. So we can have as B and then as C as equations here. So we can say our C is equal to negative 4 plus 3b. So that would be our C. So equating this two, we can say our C is equal to negative 4 plus 3 times 3 minus A. So that would be in terms of A. 9 minus 3A. Combining similar terms, our C is equal to negative, or rather 5 minus 3A. So we have our B, we have our C. So how about our A and our D? Okay. So for that case, that's kind of impossible, but we can inspect and then we can eliminate some of the variables. So C 5 minus 3A, D is 3 minus A. So these two are equatable. So we substitute it here. We have A. So we substitute B here. We have twice A, D, and E. But what we need is this one instead. Okay. So that makes elimination more convenient here. Okay, so combining 1 and 2. So we have here. So 3 is equals to A plus B. And then we have negative 4 equals to negative 3B plus C. Multiplying 3 on the equation number 1. So we have here 9 is equals to 3A plus 3B. And still we have here negative 4 equals to negative 3B plus C. So that will have 5 equals to 3A plus C. Let this be our sixth equation. Okay. So we now have our sixth equation. So let's try to eliminate the variables further so that our process will be easier. Okay. So A and C, A, C, and E. Okay. So let's try to remove D here for 3 and 4. So if we remove D and 3 and 4, so we have here 13 equals to 4A plus 2B minus 3C plus D. And then negative 11 equals to negative 6B plus 2C minus 3D plus E. Okay. So if we multiply 3 in equation number 3, that becomes 13.9 equals to 12A plus 6B minus 9C plus 3D. Okay. So adding the two leads to 28 equal to 12A. This cancels out and this also cancels out. Okay, 12A minus 7C plus E. That is be our seventh equation. As you can see, the fifth equation and the seventh equations has A, C, and E. Okay, so both of them has A, C, and E. So we combine 7 and 5. And let's link that with equation number 6. So we have here 23 equals to 4A minus 6C minus 3E. So what we're going to eliminate is 2. Let's eliminate E so that it can be equated with equation number 6. So we multiply 7 with 3. All of them would be would be multiplied by 3. Or it will be Yes, yes, yes. It will be more, it will be better for that one. So 23 for A minus 6 minus 3. Okay. So we'll multiply everything here by 3. So that will have 28 equals 2, or rather 28 times 3. So 28 times 3, so you have 4, 6, 84. Okay. So 84 is equal to 12 times 3, so that is 36A minus 21C plus 3E. Okay. And then equation number 5 remains as is. So 3 and 3E will be canceled out, okay, by addition. So this would be 107 equal to 36 plus 4, so 40A minus 27C. And this would be our 8th equation. Okay. So equating 8 and 6, so we need to remove either A or C. So for this case, let's try to remove C by multiplying it by 27. So that the equations become 107 equal to 40A minus 27C. So 5 times 27, that's that. Sorry for that one. So 27 times 5, so 535, 135. It's equal to 27 times 3. 1 carry 281. And then C would be plus 27C. Combining these two, this cancels out. 107 plus 135. So we have here 2 carry 1, 4. 242 is equal to 121A. So that our A is equal to 2. And that is our first coefficient. Okay, we now have our letter A. We can now find letter C by substituting it in this equation. So that C would then be equal to 5 minus thrice our A, which is 2. So that our C is equal to 5 minus 5, or rather 6. So that our C is equals to negative 1. So we have A, we have C. We can solve our E. If you can still recall, okay. So A, C, and E. So we can now solve for our E. So to solve for our E, let's use that equation. Okay, so 23 is equals to 4 times our A, which is 2, minus 6 times our C, which is negative 1, minus 3 times E. I just took over here. So 23 is equals to 8. Negative and negative, that becomes positive 6 minus 3. Okay. 8 plus 6, that's equal to 14. Okay. So 14, so 23 minus 14 is equals to 3, negative 3. So 19. Okay, so that is 9. So 9 is equals to negative 3E. So that our E is equals to negative 3. Oh, we have A, we have C, we have E. Now we can solve for the other parameters. So let's try to solve for our B first, since that is isolated here. The value of our A is equal to 2. Okay. So we have here 3 is equals to 2 plus B. Transpose the other side. So that our B is equal to 1. Okay. We have our A, we have our B, C, and E. What was left is our letter D. Okay, so for letter D, let's just use the third equation. So 13 is equals to, what's the value of our A? So that is 2. So 4 times 2. plus 2. What's the value of our b? It's negative, or rather just 1. So 2 times 1 minus 3. What's the value of our c? So c is equals to negative 1 plus d. Okay. So this becomes 13 equals to 8 plus 2 plus 3 plus d. 8 plus 2 is 10 plus 3, so that is 13. Transposing that to the other side, our d is equal to 0. We now have solved all of the arbitrary constants. Therefore, the decomposition of the equation would be equal to our a first, or our a over x minus 3 the value of our a is equal to 2. 2 over x minus 3 plus, okay, the first repetition, our b equal to 1 times x, so that would be x, plus our c equal to negative 1. Since that is negative 1, this becomes minus. Over the first irreducible trinomial quadratic function, or factor, oops, what's that? Which is x squared plus 2. Plus our d is 0, so therefore we can neglect that. But we have the value of our e equal to negative 3. So if that is negative 3, therefore we multiply this 2 so that it is better written as 2 over x minus 3 plus x minus 1 over x squared plus 2. Okay, instead of plus, that would be minus 3 over x squared plus 2 quantity squared. And this is now the decomposed answer, which is also written in this part. Okay, so do you have any problems or questions with regards to this topic? Okay, so I'm going to give you some exercises for you to practice. So try to decompose this. So try to decompose these problems. On your own. So this is not that required, but for you to be practiced and prepared for your exams. So only 2 problems for you to practice. So this is not compulsory, but this is just some chance problems or some exercise for you to further hasten your skills in this topic. Okay, so this concludes the lecture, or this concludes the topic for this session, and the required topic for this particular class. So if you have any problems or questions, don't hesitate to send me a private message. I'm always here to serve you and to clarify your questions. So Surgeon is always here to help you out with your problems. So thank you very much for listening to this topic. Hope you're enjoying the lecture. So see you on the next video of our lecture.